Okay, chapter 5, deformation of the Earth's crust. So what we're going to be talking about today is some really cool stuff. For me, it's kind of like baking a cake. And I know you're not going to see that right away, the connection, but I guarantee by the time we're done, I will make the connection to what we're talking about and cake baking. I like a good cake, so I mean that works out pretty good. So, deformation of the Earth's crust. Our objectives today is we are going to figure out and predict isostatic adjustments, understand what that means, understand how we have changes in the Earth's crust. That's number one. Number two, we're going to come up with and identify sources of stress. Now, I'm not talking about your significant other getting mad at you type of stress. I'm talking about stress from cracks and movement of plates, and we're going to talk about that. Now, so the first thing we have to do is understand what deformation is. Now, if you look at my face, there's been some serious deformation take place here, right? Mr. Borrego's going, yeah, your face is really deformed. No, that's not what I'm talking about. What I'm talking about is we're talking about the Earth changing as a result of our plates, as a result of movement of some sort, whether it be parts of it breaking off and moving to another place, or whether it mean that we have some sort of a bending taking place. And I'll explain how that's kind of like toothpaste here in a minute. So what's the major cause? Plate tectonics. Plate tectonics is really what makes everything move. And we talked about this sometime back when we talked about the fact that our mantle and we have massive amounts of magma moving with convection currents underneath the plates. And as they do, kind of like a bowl of spaghetti, they move too. And so if we look at this picture here, this is a really good indication of what we're talking about when we talk about stress, right? So if you look at this picture, you got this individual on the right pointing. That person's hand is on an earthquake fault. And if you look just to the left of it, which is in the next place, that is another earthquake fault, right? So we have this two faults sitting there. But if you look a little bit deeper into this picture, right, because this picture tells a lot. Look a little bit deeper, what do you see? Well, first of all, it's at an angle. Can everybody see that? The rocks are at an angle, kind of like pointing towards that guy or a girl. What is it? It's a guy, but those are some serious short shorts. I'm telling you that right now. I didn't wear those when I was in high school. I'm telling you that. So when we look at that, it's at an angle. Well, when you bake a cake, what do you do? Dylan, do you bake cakes? You don't bake any cakes? He baked pies. Okay, bake pies. Let's talk about baking cakes. Anybody in here bake a cake? Hunter, you bake cakes. All right. When you bake a cake, how do you bake it? How do you make a cake? Go buy some ingredients. Mix them up, throw them in a bowl, mix them up. Wait a minute, you forgot a step. You can't just put the whole bowl in the oven. You pour it into a pan. When you pour it into a pan, is it at an angle like this rock right here? Is it are there cracks in it? No, it's flat, right? It goes to the least path of resistance, gravity, right? Would you agree? Okay, Aiden, you're not a very good cake baker, by the way. So as it happens, you lay it flat. Well, that's the same way with our Earth. All of the dirt, all the sediment, all the rock, it lays flat. Now, over time, that builds up. As it builds up, all of a sudden, things happen, and it tilts. So for this instance, this rock was once flat, but now it's tilted, and it's got these waves in it. We'll talk about that here in a minute. We have two faults. In other words, the rock has slipped as the plates have moved. So one of the things that we call is isostatic adjustment. What's iso mean? You ever do a football play? ISO? What's ISO? It's isolate, right? Well, the other thing is as it does, we are looking at same adjustments or adjustments in the Earth, whether it goes up or down. So if you look on the far right, you can see this massive, massive amount of weight from ice. As it's doing that, it's pushing down. Well, it's been pushing down, pushing down, pushing down, and then when it melted, it's no longer as heavy because water's evaporated, it's gone. Now, it's either going to want to rise or it's going to move laterally. And in this case, you can see on the bottom picture here, hey, it's wanting to go up. Now, as we see the weight added or subtracted, it's either going to go up or down. And so you can see this crust, this mantle underneath this, eventually will have some change. It's deformed. All right, here's the deal. If we think about the heavier parts, they push down into the lighter parts, and it changes. Isostatic. It's either up or down. It's trying to find a balance. So if we look at Canada, right? Areas of Canada where we've lost the ice, where the glaciers have melted, they're rebounding. They're going up. They're rising in elevation because that weight has been lifted. Now, I'm not talking like a freaking balloon or anything like that, but it's going up. Isostasy or isostasy, however you choose to pronounce it, potato. Basically, it's that balance as we look at it going up or down. Is the Earth's crust is basically in flux. In this particular image here, we have the crust of the continent and we have the crust of the ocean. And what we have is a displacement of the mantle. We are looking at a displacement of our crust because we have this mountain here. Well, as a result of it, it's pushing down. It's pushing down into the asthenosphere, which is plastic. It's like toothpaste, liquid toothpaste. Okay? So it either goes up or down depending on where we're at. Now, if we have continent going underneath underneath the land, in other words, subduction, we'll talk about that. If we have it going underneath, then it's going to push the mountain up. We're seeing changes. All right, so what are the causes? Well, erosion. Our mountain is worn away, it got lighter, and it's pushing up. That's number one. So if we lose material, it's lighter. I'll give you an example. If I put a semi-load of gravel on top of refot, and I take half of the semi-load away, it's still heavy, would you agree? Yeah, refot's still underneath there. However, it's not as heavy as it used to be. And if it was pushed down, now by the way, refot's still not doing very well at the bottom of this thing, but if it's pushed down, now the resistance is not as much. So in other words, it becomes less weight, less dense, and now underneath, because it was pushed into the lithosphere, it wants to push up. Pushed into the asthenosphere, wants to push up. That's what happened. That's number one. Number two, we have a river. The river carries stuff away as it erodes away. Okay, makes sense. So where's it going? Well, Vermilion goes to the Illinois, goes to the Mississippi, goes to the Gulf of Mexico, right? So as that happens, now all that stuff that was out here, where's it at? It's at the Gulf of Mexico. Now the Gulf of Mexico is getting heavier, right? Does that make sense? And again, let's go back to Hunter's cake. As it goes into the Gulf of Mexico, it goes flat. It's pushing out there flat. It's falling flat. Gravity makes it as flat as it can be. And then the third one is glaciers. Now, right now we're in a glaciation eroding period, so it's going away. As it goes away, guess what? It gets lighter. If we got more glaciers, it would get heavier. Retreat, advance. And the reality is it's pretty simple if you think about it. You either have more or you have less. If we look at the glaciers that we have or used to have on our continent, North America, they're gone. So as a result, this area in red and yellow, we're seeing a rebound. It's going up in altitude. Why? No, it's not above everybody's head because it's all on an even plane, but it is going up. And the reason why it's doing that is all that ice is gone. It's not there anymore. So, our plates are moving. They cause stress. As they cause stress, things break, things move, things shift. As they shift, we see the plates shift. We call that stress. Okay? So, stress is what you do when you apply it to a rock. Now, here's the deal, and I'm going to be honest with you. Some rock is more susceptible to stress than other rocks. So, as we change the deformation of everything, it's called strain. What's going on to us? Well, I'm straining. I got to lift all this rock. Well, same thing here. That deformation is called strain. What caused it is called stress. So you have stress and strain. All right. So I want to show you this clip. Hold on here. All right, here we go.
The three sets of rocks in the Grand Canyon, the upper one, the Paleozoic, the Tepete sandstone, which we saw earlier, was flat-lying. It was deposited on a beach as layer after layer of sediment.
There's Hunter's cake.
Accumulated and then became lithified. So what is happening here? These flat-lying rocks are no longer flat, obviously. They're almost vertical. They've been turned up on end by major tectonic forces in the earth. So to a geologist, this is a place of interest. It tells us about processes and a major uplift event which deformed or bent the flat-lying strata. So what can we learn about this? We see them turned up. They must have headed up that way, and they then exit above me here to the west onto the Kaibab uplift, the East Kaibab uplift. This is the edge of the East Kaibab uplift. It's a place where the otherwise flat strata of the Colorado Plateau have been wrinkled and bent by major compressional forces during the Laramide orogeny, which lifted up the whole Colorado Plateau and especially lifted up the Kaibab uplift relative to the block on its side.
So what this guy basically just described was how the stress has changed the Colorado Plateau, right? Okay, what are our main three types of stress? Okay, convergent, divergent, and transform boundaries. So when we think about this, okay, converge. All of us are going to converge on the football field this afternoon, and we are going to cheer on our team to victory. What does converge mean? Come together. Come together right now over rocks. Okay, so what happens is convergent. We are compressing. We are coming together. So what happens as we compress? We're pushing towards the middle. As we're doing that, what happens? We start to see more material in the middle. It goes up. All right, so that is a stress. The strain is we see it going up or getting thicker. Now, the divergent. Now, I'm not talking about the series, but what does the divergent mean? Well, we could talk about the series. What's this divergent series about? Nobody saw this? You don't remember? Going up, it wasn't that bad, Zach, but so what happens is it's going away from the middle. It's trying to go away from the norm. It's diverging, right? Makes sense? Going away. So what happens as it does, we have stress, which is called tension. We're pulling apart. So I'll give you an example. If I give Dylan a piece of Laffy Taffy and I hold on to it, and we pull, what's going to happen? It's going to stretch until when? Eventually it's going to break. Everybody agree with that? You cannot pull Laffy Taffy across this room. I don't know. What do you think? A foot? How far do you think we can get? Meter? 2 meters? What do you think? Not very far. Centimeters? Not very far. Well, that pulling apart is called tension. All right? So we have what's called a normal fault. In other words, the fault is one that slips in or slips down. Transform. Now, we're not talking about the Transformers, Dark of the Moon, or anything like that. There we go. Okay, we got somebody. Okay. Zach says Transformers rule. All right, transform means we go side to side. So one side is going forward, the other side is going backward. These are the main 3 types of stress. These are the main 3 types of the way our planet moves. So it moves to each other, away from each other, or side by side. Everybody get that? Anybody who doesn't get that? Everybody's good? All right, I'm good. Okay, here's what we're going to do. Tomorrow we're going to talk about the results of stress. We're going to talk about the results of stress and what happens. Recap. We have convergent, divergent, and transform boundaries that move. We have stress, we have strain. Strain is the result of what happens. Stress is what causes it. All right, you guys did great. Thanks for listening. And if I can shut this off, you guys have a great day.